Hi, everybody. Welcome back. Well, we're on week 13. This week, we're going to talk about digital preservation in several different forms. First, we'll talk a bit about conventional preservation issues regarding digital materials and digital preservation planning. And then we'll spend the rest of the learning module talking about web archiving, and you'll get some practice time in with some web archiving tools. Now, as we initially discussed when we were building our information lifecycle models earlier in the semester, there comes a point in the life of any type of digital information where its value starts to decline, as well as its usage and its utility to the organization that produced it. However, a lot of digital information does not entirely lose all of its value. Certain types of sort of common communication types of information, like emails, probably 80-90% of the emails you receive over a short period of time are going to lose all their value and not be worth archiving. There's probably another 10 to 20% of your emails, however, that aren't going to lose their value. The same thing with documents, images, audio, video, etc. And then there's another class of information that retains long-term value as a digital object. Those might be types of audio-video media that are being recorded for posterity. They might also be documents that are needed for legal purposes. There's a variety of reasons why we need to preserve digital content. We need to be kind of judicious about saving content for the long term, both because of the cost and the labor involved in reconstituting preserved information. And it's important to note that preservation is not an inexpensive issue. It's rather expensive. Whether you're preserving paper documents or digital documents, there's still ongoing costs involved with that. And really, unless you set an end date to where you know that your digital information has no more value and can be discarded, preservation costs are ongoing. They don't have any ending point, so they're an accumulative cost to your bottom line budget that will never go away. So the value of the content the needs to determine the amount of preservation investments you're going to make into your digital materials. Now, some content is going to be very valuable for the short term or the mid-term, but it won't have any value long term. Other content is going to be valuable for the long term from the point that it was created to forever. So when we design our information life cycles, we need to categorize the type of value proposition that each type of information that we are going to preserve offers to the organization. Whether it's going to be valuable just in the short term, mid-term, long term. And that's what's going to control how much investment we make in ongoing digital preservation. Now, in essence, preservation means we are going to not only save material, but we're going to save it in its original form so that we can go back and access it in its original format, or at least as close as we can to the original format that the content was created in. And it's important to save some classes of content in the absolute original context that it was created in. Other content can be saved as data extracts or summary or abstracts or some other form of content that is a surrogate or a substitute for the original document or media object that was preserved. So that's an important determination to make. So planning is imperative to a successful digital preservation program. And there are really 4 different aspects that we need to consider in a digital preservation plan. Now, the first one is determined by how high a fidelity we need to keep. How close to the original content do we need to preserve the digital object for the long term? When we talk about fidelity, we mean sort of the truth or the reliability inherent in the object. So we're all familiar with high fidelity audio, meaning it's as close to actually hearing the real sound as possible. Well, there are certain types of digital content, usually graphics, images, audio, and video elements, that need to be saved for the long term at the highest level of fidelity that we can get for them in a practical sense. We'll talk more about that in a second. As I just alluded to, knowing how long to keep your digital content is also very important. We call this the retention plan or the retention schedule. That's a term that's used in the field of records management quite a bit. But essentially, you determine by type of content how long it's going to be valuable in legal terms or in historic terms or in simple business operations terms. You're going to determine how long that content is going to remain value. And then once it reaches a certain point where its value is severely declining to the organization, then as a matter of practicality, you can determine to cut it loose and essentially destroy it or dispose of it, and not have to pay the cost of preserving it any longer. Storage media is another issue that needs to be considered. Storage media, the disks, the hard drives, etc., that we store data on, is not perfect by any stretch. In fact, it lends itself to dissolution in not a very long period of time. There is a good argument to be made that paper lasts, when it's preserved properly, lasts a lot longer than any digital storage media is ever going to. Now, that's going to change over the next few years as technology improves and evolves. And in fact, we're seeing more of the solid state drives, which lend us hope for the ability to store data long term without a lot of environmental concerns about the data degrading due to heat or light or water, for example. So technology is going to take care of the longevity issue, but for the moment we're still stuck with a lot of magnetic media, a lot of optical media, and there are built-in problems with degradation in all of those media. So we need to have a plan for checking on our long-term storage media, making sure it's not degrading, and when we find it's degrading, to replace it with new media and to copy the content onto that new media. And then the single most complex area of digital preservation is maintaining access to the digital files or the digital content in general that we are storing. Files are created by software applications. Software applications change very rapidly. That's the nature of the industry. And we are constantly fighting the battle of trying to keep up with making old files accessible through current versions of software applications. The same thing holds true with other kinds of digital content, such as media formats, even database and structured data formats. Those can age out. They don't age out as quickly as other types of files, say word processing files, which change rather rapidly in the industry. But certainly a database that was created in, say, 1985, you're going to have a little bit of a challenge, at least, trying to find an application that's going to read it, particularly if it's a DBase file or if it's an older variant of a SQL database. You are going to need some help in getting that restored for active use. So we need to maintain a plan for checking on the ongoing accessibility of our files and data, and then saving all of the components. That could be hardware, software, as well as the files that go along with the hardware and software, and making sure that we save all the components that allow us to reconstitute and use the content that's stored in preserved data files. Now, let's go talk a little bit more about content fidelity. Some content doesn't need to be saved at very high fidelity levels. Text documents, unless they are formatted specifically and use a specific formatting and style, like legal documents, reports, ebooks, etc. Text documents might be the least of your worries in terms of saving at a very high fidelity, and those could be saved as plain text documents. Long term, maybe, and maybe not. Graphics, digital images, you can't ever save graphics, images, audio, or video at too high a resolution. Now there is some level of practicality, like if you have an old TV program that you recorded onto a VCR back in the 90s, and you save it as a high-definition video file, that's a little bit of overkill. So you do need to match the resolution of the source audiovisual content to the preservation format to make sure that you're not wasting your time or wasting valuable storage space. But if you need a rule of thumb in how to save audio, video, and images, digital images, for the long term, you need a simple rule of thumb, then saving them at as high a resolution as you can get, you'll never go wrong with that. There are also some other issues with digital media. Most digital media that you see that's published on the web, or photos that you see posted on Facebook or on even scholarly or research websites, a lot of them have been compressed in one form or another to save space and enable them to be transmitted over the internet easily without a lot of people waiting for images to download. But for preservation purposes, audio, video, and graphics and images need to be saved without compression. That enables you to get the highest level of fidelity for that digital media as possible, saving it for the long term. And saving images at the highest level of resolution, or dot pixels per inch, and with no compression is important both for historic reasons, as we see here with the George Washington banner, as well as for other kinds of business purposes like healthcare. Here we need high resolution images there. You wouldn't want medical images to be compressed when they're stored long term, so that you lose valuable data about the patient that's being scanned. Like I said, with audio and video, you need to save at the highest resolution, the largest frame size, the highest bit rate, and save it in an uncompressed format. And if you're not familiar with archiving audio and video, then there are lots of additional literature that you can access either just on the web or through the scholarly literature that'll tell you what the best specifications to determine for saving images, audio, and video are. One sort of rule of thumb that you can use that for digital media that, again, is hard to go wrong with, it's not impossible, but it's hard to go wrong with, is there are certain file formats that lend themselves to non-compressed, high-resolution digital content than others. Now, for digital images, if you save an image as a BMP uncompressed, a TIFF uncompressed, those are really good preservation formats. For audio, an uncompressed WAV file at a high bit rate, the same thing with an AVI file for video, uncompressed, and again, high bit rate. Audio and video files can also be recorded at what's called variable bit rate, which means that the bit rate, the rate that data is transmitted in the file, goes down when there's less action or less going on in the content, and goes up when there's more. And actually, for preservation purposes, you should always save audio and video in a completely uncompressed and high bit rate, not variable bit rate format. Text documents are a little more complex. Sometimes, in terms of style and formatting for complex documents like legal documents and works of intellectual property, non-fiction or fiction, saving the document in its original word processor format may be the best way to go. The other way you can capture a surrogate or a representation of an original digital text file is to save it as a PDF, specifically a PDF-A, A standing for archive, format, which will preserve all of the formatting, but it won't let you work with the actual content anymore once you capture a document into PDF form. But PDFs look like, for text documentation, they are probably going to be the long-term solution that we can depend on right now. And assuming that Adobe doesn't go out of business, then PDFs will probably be around long after you and I are gone and shuffled off this mortal coil. As I mentioned, content retention plans, determining how long the content is valuable to an organization, and then cutting it loose after it exceeds its valuable lifespan, are important factors in digital preservation planning. So the first step in creating a retention plan is to determine when you're building your information lifecycle model, what categories of information does your organization produce, and what is the long-term value of each type. Now, for legal purposes, that might be one answer. For historical purposes, that's another answer. And for operational purposes, that's a third answer. And you'll need to juggle those three answers depending on what kind of organization you work in. Now, in the private sector, for example, it's important to keep emails for 5 years for legal purposes. And then once you reach that 5-year mark, then you should destroy the emails unless you have earmarked some of them as being historically important and you need to keep them longer than that. But that's a legal and operational determination of how long to keep your email. Some emails, in other legal cases, only need to be retained for 6 months, and then it's always recommended that you destroy them after that point. Those are for proprietary and internal legal purposes inside an organization. So it's important to ask yourself, does this content that I have, this digital content, does its value diminish over time? And then you'll need to make perhaps a guesstimate or an estimation as to how long that value diminution is going to take before the content is useless. One way to deal with the unknown value of like how long content is going to be valuable to a company is to gradually phase it out and see what happens. By that I mean, for example, that you could say we're going to keep all of our data files online for a year in our operational file shares at our organization, so all employees have access to files from 1 year out from their original creation. And then we're going to move the files and sort of phase them out by moving them to an archive server where they'll still be online, but employees will have to go look in another place to get those. And then once they've been on that archive server for a year, maybe we'll just back them up to tape, or we will archive them onto a long-term preservation solution like gold DVD discs or something. And then that will give you the chance to gauge how much employees are having to look at the archive server versus the operational server. Sorry, I just hit the keyboard. Versus asking the IT department to restore archives that are offline. Online versus offline storage is another preservation option. Offline means you simply save data to either tape or disk or an a hard drive that's not connected to a server, and you store it on a shelf as opposed to keeping it online on a server where somebody can access it. That's often a way to sort of lower the cost of long-term preservation, but still keep the data around in a way that's fairly easy to access. And then finally, when you do determine that this information doesn't have any value anymore, it's best just to schedule an annual destruction period each year. That might be at, a lot of times those occur in the fall, after the end of the government fiscal year, for example, or in midsummer after the end of the private sector fiscal year. And then that gives everyone in the organization a chance to speak up if they know that every July 1 we're going to destroy content that is over 5 years old that has been determined not to have any value. If there's a chance somebody might still need content to be preserved longer than that, they know when the destruction period is going to be, and so they can speak up in advance of that and make their case to save that material before it gets destroyed. If you are just destroying content on an irregular basis, then that doesn't give end users a chance to speak up and ask for exceptions to the destruction rules. Now, as I mentioned, data storage media that we have to deal with is imperfect, very imperfect. Every type of media, whether it's a hard drive, a flash drive, a solid state drive, an optical disc, or a magnetic disc, all of it has an estimated end-of-life specification that you should be aware of. Usually this is expressed in the mean time between failures, which you can look on the specification sheet for any type of disk or hard drive that you buy, which gives you the average lifespan of that media before it will fail, either through degradation or mechanical failure. So you should always schedule a review of your content in advance of that mean time between failure specification for all of your different data storage media. And then that also gives you the opportunity to schedule regular storage migrations. And basically you need to regularly, within the the active lifespan of your storage media, schedule a migration to a brand new piece of storage, and copy the content from the old storage to the new storage before the old storage starts to degrade. This requires ongoing monitoring and testing. So that means if you're going to use gold DVDs as your archiving media, then it's important for you to take them off the shelf at regular intervals and test them and make sure, and physically inspect them to make sure that the layers in the discs aren't separating, they aren't starting to warp, they haven't gotten scratched somehow, and that they still play and you can still copy data off of them. And of course you want to jump the gun on any degradation. So if you start to see any sign of physical media deterioration, then that's the time to immediately copy the content over to a brand new storage media device. Now, as you can see, this is going to require ongoing commitment and a lot of labor. So that's why we determine when we build our information life cycles what information we really do need to keep long term and what information can be disposed of without hurting ourselves operationally. Now, the last point with digital preservation planning is that, as I mentioned, file formats are dependent on the software applications that produce them. So a specific version of Microsoft Word produces a specific version of the Microsoft Word document file format. Both of these will change within a period of every 9 to 24 months. Sometimes when software developers change their file format specifications, you don't notice. So there are versions of Microsoft Office where the Word document format has not noticeably changed from one version to the next. And then there are other versions, new versions of Microsoft Office that have caused the complete creation of brand new file formats that aren't compatible with the old formats. So most large software development companies will make a commitment to backward access. So you can open in Microsoft Word a Word document that was produced back to, say, Office 2000, if my memory serves correctly. But the prior versions of Microsoft Word in the 90s, your Word, your Word 2010 version probably isn't going to be able to read those. So you need an intermediate version between the 90s and 2010 so that you can continue to open those old Word documents. Now, why wouldn't I want to just convert all of the old Word documents that were created in the 90s to newer files? Well, in most cases, that's true. However, there are a lot of cases you'll find with older documents that if you open them and convert them into a newer format, you're going to get scrambled data, and that it might not be avoidable. Formatting and style guidelines in the document might be lost. It's just not going to look the same as it did when you created it on the original application that was used to generate the file. So, in addition to preserving our digital files, we also need to preserve the software applications that created those files. And this starts kind of an evil chain of custody issue where we not only are going to need to save an old copy of Word to open old Microsoft Word files, but you're also going to have to save the operating system that old copy of Word ran on. And that means you also might have to save an old PC or Mac that old copy of Word ran on, just so you can ensure that going forward that you have complete real access to those older data files. Now, if you don't need to preserve the absolute formatting of the data in your files, it is more than acceptable to periodically convert them and update them to new formats. And that's probably the most cost-effective way to handle long-term digital preservation, is just to, every time a new version of a software application comes out that you have archived files from, you need to test the old files, see if they work, see if there's any loss of fidelity, and then attempt to convert all of them forward, and then you can discard the old versions of the files. For some historical and legal purposes, that might not be doable, however. So it's going to be a balancing act with file access planning, that you'll have to balance the cost and the trouble of maintaining old copies of software and hardware so that you can access old files versus the labor of having to convert the files forward every time a new version of that software comes out. So that's probably enough to make our heads spin in terms of digital preservation planning. You can see, though, that it's very important to really look at the content that you're managing, determine all of the various points where content is going to age out because it's not valuable anymore, or because it's in the wrong format, or because it costs too much to maintain it. And maintain a formal digital preservation plan with your organization that works in tandem with your information lifecycle model. Now, web archiving is, now we might say, something completely different that we're going to talk about. But, just until with the last 10 years, maybe even just the last 5 years, it's been very important. It's been easy enough to capture digital content in other ways than archiving websites. You might be able to archive all the elements for a website. In fact, I have websites that I created in 1993 that I have the elements preserved, but I don't have the old browser software or the old web server software. So I'll never be able to really reconstitute what that website looked like using the Cello browser, or using Netscape Navigator, or using Internet Explorer 2.0. The sites simply look completely different because newer browsers interpret HTML in different ways than older browsers did. There's sort of a myth of standards and compatibility in that regard. And then we use in websites today, we use so much complex content that is either code generated or in proprietary formats like Flash, or new formats like HTML5, that web browsers of the future are not going to be able to easily parse and display elements of content that we are creating today. So it's important to archive your published websites or data that is published through websites for a variety of purposes. Now, one of those purposes can be to maintain the context, so you see how the original content looked, how people saw your website. It also might be important for legal purposes, and it might be important just for saving data that from a server that you don't have access, low-level access to. So you might have to go and save the data through the front end of the server. Well, there are a number of web crawling technologies or web archiving technologies that we can use these days that make it comparatively easier nowadays to archive websites than it was to try to archive a website back in 1993. All of these technologies are based on the core web technology of the crawler, which was originally invented in 1994 by Brian Pinkerton. And if you remember Lycos, which I don't believe it's around anymore, Lycos used to be one of the early web search engines that tried to crawl the entire internet at a regular basis and give you the ability to search through various web domains seamlessly. Crawling technology is a software application that when it is pointed at a web server, will interrogate that web server and find all of the public points of access that are available on that server, and then it will go and get the files that are in those public points of access, and it will either ingest them in an index, or it will copy the files down to the server that the web crawler is running on, and allow you to use that content either for preservation, which is a new application of it, or for search and retrieval purposes. Now, the traditional web crawler is a search and retrieval tool that was designed to look at a website and all of the nodes on the website, capture the indexable data, meaning essentially the text information and the structured code in some cases, on each web page, and save that in a database that can then be used for search of those websites and linking back to the websites for retrieval purposes. We can use web crawlers for preservation purposes nowadays, and you'll have the opportunity, if you want to choose a traditional web crawler and learn how to use that, to use this desktop application. I'm going to recommend that if you have access to a Windows or a Mac system, there are 3 tools we're going to look at by a company called NewProsoft. You can get the trial versions of these tools, but essentially these three applications sort of encapsulate all of web archiving technology at a desktop level that is easy to learn and understand. If you don't have access to a web or an Apple machine, then you can use an open source crawler or archiving tool, or you can use a retrieval tool like wget, which we'll talk about here shortly, as the tool for your assignment, which I'll explain in a little more detail in just a minute here. But we can use, going back to this application here called Visual Web Spider, made by NewProsoft. This is a desktop application that you can point to one or more websites, and it will automatically interrogate and index the content on those websites so that you can use basically a search and retrieval system to find the content. You can also save the indexed content, but it won't be in the same format as the web page. Essentially, you're just going to save the text data into a database. That the text data will be sort of munged together from every web page, and each web page will then become a record in a database, so that you can continue to search and say, okay, well, on this site, on this date, we had a page about Peruvian history, but you won't be able to reconstitute that page and view it in a browser. You're simply going to save the indexed information that allows you to search for that page as it occurred on that website. So web crawling tools are useful if we want to index concepts rather than visual pages. If we want to say on a certain date when an important event happened, we want to index a whole variety of websites and see what they had published about this event on that date. That's a good use for preservation purposes, to use a web crawling tool. However, usually we want more when we archive a website. So if you just need the data, and you need to be able to use data off of a website, so for example, you need to copy a catalog off of a website and then save it into a database in multiple columns and rows, or a spreadsheet even, you can use what's called a data extraction tool. Now this will comb a website for usable data that fits a certain pattern, like a record structure. And then it will save that record data into a database that can be, essentially you can do sort of a pseudo reclamation of the data after it's been saved. So you could republish the data in its original structured form using the extracted content that you saved using this tool. This particular tool by NewProSoft is called the Web Content Extractor, and it's an excellent one for saving structured data off of websites. Now the third kind of tool actually downloads the entire web page, including all of the graphics and the animation and the code pieces, at least as many as the server that's being crawled will let the application access. And then it reconstitutes all of the page elements, the display of the page, and the links that were on that page to other resources that you've hopefully captured. And so you're essentially recreating the website locally. This is an excellent way of archiving websites, especially if you mainly just need the data that was on the website, the information on the websites. You don't actually need all the administrative and technical pieces behind the scenes or under the hood of the website. This tool by NewProSoft is called My Offline Browser, and it's really what's called a scraper, a web scraper. It goes and scrapes the page and it pulls data out and reassembles it locally for you. But it allows you to do very complex archiving jobs for websites that can be huge and save them in comparatively small space, on a local hard drive. So it's a very good content archiving tool for web purposes. Now there's another scraper, which is actually a subscription service, and there are a couple of these services around, but the best known is called ArchiveIt, and it's a subscription service where you pay money each year to be able to use the Internet Archive organization's own web crawling technology to capture and save web pages that you direct. Now, we have a subscription to this service here at University of New Mexico Libraries, and we're using it for a variety of purposes. A lot of content, for example, is that's posted in other countries is not indexed by Google or any of the major indexing services. So ArchiveIt allows you to save and archive the websites that are published in South America, for example, or in Africa, where Google doesn't necessarily reach. It also allows you to create really good archives of local websites. So we have an archive set up here of the UNM Today online newsletter that UNM produces, and we archive that on a monthly basis as each new issue comes out. Now, the Internet Archive developed a web crawler and extraction tool called the Heritrix search engine. I've got a link at the end of the lecture here that you can go to learn more about that. And it's actually an open source piece of software that you can download and install on your own machine, so you don't have to subscribe to ArchiveIt and pay money to use the Internet Archive's own web crawling technology. But Heritrix is probably the most advanced scrape and capture and index sort of hybrid web archiving tool around. That's unless there are maybe some commercial versions that are proprietary that are not as publicly available. This is the control panel for our UNM ArchiveIt account that shows that we have archived, at this point, this is an old screenshot, 17.4 gigabytes of data and 171,000, almost 172,000 web documents or pages. ArchiveIt lets you crawl with a variable frequency, so you can do it every day up to once a year, and you can select what websites, they're called seeds in archiving parlance, what websites that you want to archive, and you can have basically as many websites as your subscription plan will allow can be archived at one batch. So ArchiveIt is an excellent institutional tool for a mid to large size organization that can afford the subscription rate, which is probably going to be around $5,000 to $10,000 a year, depending on your data archiving needs. Now, the new ProSoft My Offline Browser and ArchiveIt work the same way in that they go interrogate a website that you point them to, and then they save the visual representation of the page in as accurate a manner as possible. ArchiveIt puts this little archived banner up top. You might have seen this on the Internet Archive as well. But this gives you the opportunity to save and come back to pages that have gone offline and see what they originally looked like, or at least as close as you're going to be able to get to seeing what the original content looked like. Now, to end up here, I just wanted to mention the different kinds of tools that you have available to you for web archiving. As I mentioned, Heritrix, produced by the Internet Archive organization, is probably the most advanced, and they are offering it free as open source software, so you can create your own Heritrix archiving site. Now, you might need to write some code or configure the system so that you can control how sites are archived and view the archived content. But essentially, all of the heavy lifting has been done by the Heritrix engine. Methanol is another free open source web crawler. It is sort of community maintained, so it has gone through several stages where it hasn't been maintained that well. Last I looked, it's doing okay, but you can. This is another free open source application that you can use for web archiving. New ProSoft makes desktop web archiving tools, so they aren't going to be sufficient for sort of archiving an entire company or a large organization. But if you have personal web archiving needs, these tools are going to work great, and they install on your Windows or Apple-based machine. And the one drawback is that they cost money to get the full licensed version. Now, for our assignment this week, I'm going to ask you to download the trial version. You don't have to enter any of your contact information to get the trial version, and I think it's good for 30 days. So you can pick any of the 3 new ProSoft applications that they offer. There's Visual Web Spider, which is just the indexer, the Web Content Extractor, which is the data extraction tool, and then there's the My Offline Browser tool, which I don't have listed here, sorry, but they're on the same page here that's listed here. The My Offline Browser, which works like the ArchiveIt archiving service and actually downloads the content. If I was going to pick one for to get the greatest effect in web archiving, I would either pick the My Offline Browser or the Web Content Extractor. The offline browser is very easy to set up. Web Content Extractor is a little more challenging because you have to teach the application what kind of structured data to look for on a website. And the Visual Web Spider is great. Will show you how the indexing process works and lets you do the search and retrieval functions of a web crawler, but it's not going to be good for actually reconstituting a website. So just to review this week's learning module real quick. I've got a fairly lengthy essay on both digital preservation issues and web archiving on the introduction page. Make sure you take a look at that. You just finished the online lecture and the slides are available as PDF file to download. I have a number of assigned readings this week. I think there are at least 3 that deal with digital archiving and preservation issues, specifically 2 others that deal with web archiving issues. They are all very good articles. There are also some further reading articles on both digital preservation, including a metadata structure and standard called PREMIS, which stands for Preservation Metadata Information Standard or something like that. That was developed by the Library of Congress for describing digitally preserved content. If you're going to work in digital preservation at all, it's important to understand that standard. And then there are also several other web archiving articles that you can take a look at. One of them is an ArchiveIt brochure, which is kind of fun. Now for the weekly assignment, what I want you to do is select several personal or educational or public, very public web sites that you would like to archive. And then I'd like you to take the tool of your choice, one of the new ProSoft tools, and there's more information on how to download those on the weekly assignment instructions page, the introduction page. I'd like you to select one of those tools and download it and make an attempt at archiving those sites that you selected. Archive at least 3 different sites that aren't related to each other. You may find that some sites will block your archiving attempts. That's because they have security restrictions on the sites, or perhaps the content is code-based or database driven and your archiving tool isn't smart enough to access it. So you might have to try several different types of sites. But archive those 3 sites, and then I've given you a list of items to write up in a summary report of the experience and talk to your classmates about how well the archive experience went for you, the web archiving experience. Read at least 3 of your classmates' postings and comment on them. Now, if you, as I mentioned, if you don't have access to a Windows or a Mac machine, you're welcome to choose any sort of other web extraction or web retrieval software that is open source and you don't have to pay a fee for. You might want to use wget. If you choose that tool, I would say try to do some advanced scripts or configuration for wget. That tool is very simple to use for simple purposes, but it'd be interesting to see how sophisticated you could do a retrieval of a website using wget and have it reconstitute on your local machine in really good archivable condition. You can also use one of the other tools, either that we've mentioned or that you find on your own if you can't use one of the new ProSoft tools. So have a good week and have fun with the assignment. Web archiving is something I really am intrigued with as we go forward, because I think more and more we're going to have to find ways to technically archive entire websites in an abbreviated way so that you can see both the front end of the website and the back side, the administrative side of the website, and save both of those aspects of a website for preservation purposes. Right now, the tools that and technology we have are primarily oriented toward grabbing data off the front side of the website and not what goes on under the hood. So web archiving is a really fascinating area, and I think you'll have fun with the assignment. As always, if you have questions or need help, call me, email me, or come by the office on Tuesdays, or make an appointment for another day. So have a good week. Bye.